So in this video, I'll be covering a topic in computer networks called switching techniques. So we will try to understand what is switching and the various switching techniques. So switching is in computer networks helps in deciding the best route for data transmission if there are multiple paths in the large network. They should also provide a feel like one-to-one connection. So the various switching techniques are circuit switching, message switching, and packet switching. And packet switching has two approaches. So the first approach is datagram approach, and the second approach is virtual circuit approach. So first we'll see circuit switching. So in circuit switching, there is always a dedicated path that is established between sender and the receiver. So it means between the sender and the receiver there will be a dedicated path. Before data transmission, connection will be established first. It means before the data is transferred, we have to establish a connection. Once the connection is made, then only the data transfer happens. So an example for circuit switching is telephone network. Telephone network is a well-known example for circuit switching. So the sender first dials the number. Once the connection is established, then they can talk to each other. So the dialing a number and establishing the circuit is the same. So this is the first phase. Then the data transfer happens. So the three phases in circuit switching are connection establishment, data transfer, and the last is connection disconnection. Now we will see the second technique, which is message switching. In message switching, it uses store and forward mechanism. It means the message is transferred as a complete unit, a single unit, and forwarded using store and forward mechanism at the intermediate nodes. So it is not suited for streaming media and real-time applications. For example, suppose if sender wants to send a big data, and this big data cannot transfer in a single switch, so it will be broken into individual entities or pieces. So each of the pieces are transmitted to the intermediate nodes. This intermediate nodes received all the small pieces and constructs the full message, full or the complete unit. So after getting the complete unit, then only it will forward the data. So this is what message switching means. Now we will move on to the third switching technique, that is the packet switching. So the packet switching, a great example for packet switching is internet, in where the message is being broken into individual chunks, and each of the chunks are called as packets. So this is what the packet switching is about. So each packet is sent individually. So this is a difference between message switching and packet switching. Suppose if there is a big message and the message is broken into five pieces, these 5 pieces will be sent individually. So for this, each of the pieces should have some informations. Therefore, each packet will have some source and destination IP address. With addition to source and destination IP address, we will also have sequence number. So because we know that each packet are sent individually, so it can be received at the receiver at any order. So the sequence number will help the receiver to reorder the packets, or if any packet is missing, this sequence number will help to detect the missing packets. At the same time, this sequence number will help the receiver to send acknowledgements. Say for example, if a packet number 5 is received, it will send and the packet number 5 and an acknowledgement to denote that the packet number 5 is received. Let us take an packet number 6 for example, and if this packet is not received, then it will not send any acknowledgement to the sender. So the sender will wait for the acknowledgement for a certain period of time. If there is no acknowledgement received from the receiver, then the sender will conclude that the packet is lost and will retransmit the packet. So the sequence number will help the receiver to reorder the packets, detect missing packets, and to send acknowledgements. So basically, packet switching has two approaches. The two approaches of packet switching are datagram approach and virtual circuit approach. We will see datagram approach now. So datagram packet switching is also known as connectionless switching. It means each independent entities is called as datagram. If the message is broken into 5 pieces, then each of these 5 pieces will be called as datagrams. And each datagram contains destination information, and the intermediate devices use this information, this destination information, to forward the datagrams to the right destination. Suppose if the original message is broken into 5 datagrams, each datagram will have destination information, and this destination information will help the intermediate devices to forward the datagrams to the right destination. So in this case, each datagram will choose a different route. So in datagram packet switching, the path is not fixed. It is the responsibility of the intermediate device nodes to take the routing decisions to forward the packets. It will forward the packet to the right destination. So we will see the next approach, which is virtual circuit approach. Virtual circuit switching is also known as connection-oriented switching. So in the previous case, that is the datagram approach, it is connectionless, where individual datagrams take different routes. But in the case of virtual circuit approach, a pre-planned route is established between the before the messages are sent. So before sending the messages, some route are decided using some virtual circuit identifier. Call request and call accept are special packets which are used in this scheme to establish the connection between sender and the receiver. So in this approach, the path is fixed for the duration of the logical connection. In this previous technique, that is the datagram approach, the path is not fixed, but still it is a packet switching approach technique only. In this virtual circuit approach, the path is fixed for a duration of a logical connection. So now we will have a simple recapture now. So basically, switching means finding the best route for transferring the data from sender to the receiver, particularly in a large network. So the switching basically acts as 3 techniques: circuit switching, message switching, and packet switching. And packet switching has 2 approaches, datagram approach and virtual circuit approach. So in this video, we have understood what is switching and also what are the various switching techniques such as circuit switching, message switching, and packet switching.